Have you ever stood on a beach, looked out at the vast flat horizon, and wondered? For most of us, the idea of a spherical Earth is a fundamental fact, as certain as the sun rising in the east. But what if I told you that in an age of space travel and satellite imagery, a growing community is challenging this very notion? Welcome to the fascinating and often bewildering world of the flat Earth debate. For centuries, humanity has sought to understand its place in the cosmos. Our journey to mapping the globe is a story of exploration, mathematics, and incredible intellectual leaps. Ancient Greek thinkers like Pythagoras and later Aristotle were among the first to propose a spherical Earth based on observations. They noticed that ships disappearing over the horizon vanished whole first, and that the constellations in the sky changed as one traveled north or south. Eratosthenes, a brilliant Greek mathematician, went a step further. Around 240 BC, calculated the Earth's circumference with astonishing accuracy, using nothing more than sticks, shadows, and his own sharp intellect. He observed that on the summer solstice, the sun was directly overhead in Syene, Egypt, yet cast a shadow in Alexandria further north. By measuring that shadow's angle, he deduced the planet's curve. This wasn't just a guess. It was science in action. Fast forward through the age of discovery, explorers like Ferdinand Magellan circumnavigated the globe, providing the ultimate physical proof. Then came the scientific revolution with figures like Isaac Newton, who explained gravity, the very force that pulls everything towards the center, forming a sphere. Each discovery built upon the last, creating an unshakable foundation for our understanding of a round planet. The 20th century gave us the ultimate perspective. On December 24th, 1968, the crew of Apollo 8 transmitted a photograph that would change humanity's self-image forever. Earthrise, stunning image of our vibrant blue marble hanging in the blackness of space. For the first time, we could see our home not as a flat map, but as a beautiful finite sphere. So with all this evidence, why is the flat Earth theory gaining traction today? The modern flat Earth movement is largely a product of the internet age. It's a community built on social media platforms and video sharing sites, where ideas can spread like wildfire, unburdened by traditional fact-checking. So what do they believe? The most common model describes Earth as a flat disc-shaped plane with the Arctic at its center. In Antarctica, it's not a continent, but a massive ice wall, hundreds of feet high, encircling the disk and holding in the oceans. What about the sun and moon? They are described as small, local celestial bodies, acting like spotlights that circle a few thousand miles above the disk, creating day and night cycles. Proponents of this model offer their own set of proofs. They argue that the world around us appears flat. They conduct experiments attempting to show the absence of curvature over large bodies of water, often using lasers or high-zoom cameras. They question why we don't feel the Earth's rotation, a spin of over 1,000 miles per hour at the equator. And they point to the horizon, which always seems to rise to eye level, no matter how high you ascend. As evidence against a curving surface, to them these are not just questions, but fundamental flaws in the globe model. Of course, the scientific community has answers for every one of these points. The reason the Earth looks flat is due to its immense size. The curve is so gradual that it's imperceptible to the human eye over short distances. Experiments trying to disprove the curve often fail to account for factors like atmospheric refraction, which can bend light and create optical illusions. As for not feeling the spin, it's because everything the ground, the atmosphere, is moving along with it at a constant velocity. It's like being in an airplane cruising at a steady speed. You don't feel the motion unless it changes. And the horizon? It doesn't actually rise to eye level. As you gain altitude, the horizon drops further and further below you, a clear sign of a curved surface. The most powerful evidence for a spherical Earth, however, comes from sources that are verifiable by anyone, anywhere. Take a simple lunar eclipse. This is when the Earth passes between the sun and the moon, casting its shadow on the lunar surface. In every single lunar eclipse ever recorded, that shadow is round. The only shape that consistently casts a round shadow, regardless of its orientation, is a sphere. You can also observe this yourself. If you watch a ship sail away, it sinks below the horizon. If you call a friend in a different time zone, they will experience a different time of day. These aren't complex theories. They're everyday realities explained perfectly by a globe model and completely nonsensically by a flat disk model. So why does this belief persist? The psychology behind the flat Earth movement is perhaps even more interesting than the arguments themselves. For many, it stems from a deep-seated distrust of authority of governments, of scientific institutions, and of the media. The idea of a global conspiracy to hide the true shape of the Earth can be a powerful narrative. It positions believers as enlightened truth seekers who have uncovered a secret that the rest of the world is blind to. In a world that often feels chaotic and confusing, a theory like this can provide a sense of control, community, and special knowledge. It's a rebellion against a system they feel has failed them. The flat Earth phenomenon isn't just a quirky internet fad. It's a powerful case study in misinformation and the erosion of trust in science. It highlights how easily we can fall into echo chambers, where our existing beliefs are constantly reinforced and dissenting views are dismissed as part of the conspiracy. The tools that connect us, the internet and social media, can also isolate us in bubbles of alternative facts. This isn't about intelligence. People from all walks of life are drawn to these ideas. It's about how we process information and who we choose to trust. Ultimately, the debate isn't really about the shape of the Earth. It's about our relationship with knowledge, evidence, and authority. The evidence for a spherical Earth is overwhelming, built on thousands of years of observation, mathematics, and direct experience. From the ancient Greeks to the Apollo astronauts, the story of our planet has been one of discovery, not deception. But the persistence of the flat Earth theory reminds us that belief is a powerful force, and that critical thinking is a skill we must constantly practice. It encourages us to ask questions, but also to diligently seek out the answers and to understand why we believe what we believe. After all, understanding our world starts with an open but discerning mind. Thank you so much for joining me on this journey through one of modern history's most curious debates. If you found this exploration interesting, please consider liking this video and subscribing to the channel for more deep dives into the world around us. What topic should we explore next? Let me know in the comments below.